In TypeScript, type predicates are a powerful way to narrow down types. They are functions that perform a runtime check and tell TypeScript about the type of a variable. For example, the isString function checks if a value is a string. This simple check can have a big impact on how TypeScript understands your code. Type predicates shine as type guards. They help TypeScript understand the specific type of a variable within a conditional block. Here, we use isString to determine if value is a string. Inside the if block, TypeScript knows that value is a string, allowing us to safely use string methods like to uppercase. This is a neat way to work with union types like string, number. Creating user-defined type guards using type predicates is straightforward. Here's an example with a cat interface. Our isCat function checks if an animal has a meow method. This pattern is particularly useful when working with custom types or interfaces, ensuring type safety in a more complex codebase. Type predicates are particularly useful with union types. Here, the printID function accepts either a string or a number. Using typeof, we create an inline type guard, allowing TypeScript to correctly identify the type within each branch of the conditional. This prevents type errors and ensures the correct methods are used for each type. One common mistake is forming type predicates incorrectly. The return type should be a type predicate, like val is number, not just Boolean. The incorrect form does not provide TypeScript with enough information to narrow the type, defeating the purpose of a type predicate. While type predicates are useful, overusing them can clutter your code and reduce readability. Here, instead of creating separate type predicates for checking a string and its length, we combine them into one. This makes the code cleaner and easier to understand, while still ensuring type safety. Type predicates work well with other TypeScript features, like interfaces and classes. In this example, we use a type predicate to check if an object conforms to the bird interface. This is particularly handy when dealing with classes and interfaces, ensuring that objects meet certain criteria before performing operations on them. Type predicates can be incredibly powerful in generic functions. Here, we have a filter array function that filters an array based on a type predicate. This pattern allows for highly reusable and type-safe code, especially when dealing with arrays of mixed types. A tricky aspect of type predicates is accounting for null and undefined. Failing to do so can lead to unexpected bugs. In this example, our isString function now checks for null explicitly. This ensures that TypeScript correctly narrows down the type, preventing potential runtime errors when dealing with nullable types. It's a small addition, but it's crucial for robust type checking. Debugging can be challenging when type predicates don't behave as expected. Here, our isDate function not only checks if the value is a date but also logs an error for invalid dates. This kind of logging can be a lifesaver when troubleshooting, helping you understand why a particular value didn't meet your type expectations. Performance is an important consideration with type predicates. Complex type predicates can slow down your application, especially when used frequently or in large arrays. It's often a good idea to keep your type predicates as simple and efficient as possible, ensuring they don't become a bottleneck in your application. Lastly, let's talk about best practices. A well-written type predicate is clear, concise, and as simple as necessary. Here, the isArray function is a great example of a clear and concise type predicate. On the other hand, overly complex or obscure type predicates can make your code hard to read and maintain. Strive for simplicity and clarity to make your codebase more maintainable and your type predicates more effective.